Hello students, and welcome to this module of Home Tutors. In this module, I will be talking about longitude and latitude. I am still your facilitator, Kayode Babatokpe. Now, in this module, we'll be looking at some basic introductions and definitions of what latitude and longitude means. We will be looking at how to calculate distances along lines of latitude, and we'll also be looking at how to calculate distances along what we call great circles. And then finally, we will be solving quite a lot of examples. Now to the introductions and definitions. The Earth is spherical. Its radius varying between 6,360 kilometers and 6,380 kilometers. But for practical purposes, the radius of the Earth is usually taken as 6,400 kilometers. Lines are drawn on the surfaces of the Earth. They are imaginary lines, and these lines are used in locating the position of points on the Earth's surface. They are called lines of latitude and longitude. Okay? I'm sure you shouldn't go around the Earth trying to look for lines of latitude and longitude. They are imaginary lines, and their sole purpose is for locating points on the surface of the Earth. Lines that are drawn laterally from east to west are known as lines of latitude. Alright, lines of latitude are drawn laterally from east to west. And the most important line of latitude and the longest of them all is called the equator. Also, lines of longitude are drawn from north to south. Lines of longitude are drawn vertically from north to south. And the most important line of longitude is known as the Greenwich meridian. And the Greenwich meridian is the reference for all other lines of longitude. Lines of longitude are known as lines of meridians. So also, the equator is the reference point for drawing all other lines of latitude. Now let's talk more about longitude. The Earth rotates about its polar axis, and this is the line NOS. This polar axis is the straight line through the center of the Earth, joining the North and South Pole. That is the line NOS in this diagram. Now, NQS is a line of longitude. So also NGS. So these are lines of longitude. NBS is a line of longitude. NFS is a line of longitude. NRS is also a line of longitude. They are lines of longitude and they are called meridians. Angle FOG, for example, is an angle between two meridians, and this is called an angle of latitude. NFS is the line of longitude 60 degrees, for example, and MBS is the line of longitude 45 degrees west. Alright, NBS is a line of longitude, and it is towards the western part of the meridian. So, for example, NBS is a line of longitude 45 degrees west. NFS is a line of longitude which is towards the eastern part of the meridian. Therefore, for example, NFS can be a longitude 60 degrees east. And what it means is this: a line of longitude 60 degrees east means that a line drawn from that line of longitude makes an angle of 60 degrees with the Earth's polar axis. Okay, so if NFS is a line of longitude 60 degrees east, what it means is that a line drawn from F to the Earth's center makes an angle of 60 degrees with the Earth's polar axis. So also, a meridian NBS, which is 45 degrees west, means that a line drawn from B to the Earth's center makes an angle of 45 degrees with the Earth's polar axis. Note that longitude varies from 180 degree east to 180 degree west, and it is measured from the Earth's polar axis. Longitudes vary from 180 degree east to 180 degree west, measured from the Earth's polar axis. Now, latitude. If lines are drawn from left to right of the polar axis, the circle formed on the Earth's surface are called lines of latitude. For example, these are lines of latitude. The line of latitude whose center is also the center of the Earth is called the equator. It is a great circle since it gives the biggest division, and its radius is equal to the radius of the Earth. All other lines of latitude, however, are small circles, and they are called parallels of latitude since they are parallel to each other. The latitude of a point is the angle in degrees measured north or south of the equator. Therefore, point A at a latitude of 40 degrees north, while point B is at a latitude of 50 degrees south. Check out point A. It's at a latitude which is towards the north of the equator. So, for example, point A is at a latitude of 40 degrees north. Point B is towards the south of the equator. Therefore, point B is on a latitude of, for example, 50 degrees south. Now, when we say that a point is at a latitude of 40 degrees north, what it means is that a line drawn from that point A to the Earth's center makes an angle of 40 degrees with the equator. Alright? And now, also point B, which is 50 degrees south, it means that a line drawn from point B to the Earth's center makes an angle of 50 degrees with the equator. Alright? So take note of that. When you are dealing with angle of latitude, a line drawn from that point to the center of the Earth makes an angle of that latitude with the equator. But when you are dealing with lines of longitude, we are dealing with the angle between that point and the Earth's polar axis. Take note that latitude is measured with reference to the equator, and it ranges from 90 degrees south to 90 degrees north. Now let's look at distances along great circles. Since these imaginary lines, that is longitudes and latitudes, are used in locating points on the surface of the Earth, their coordinates will represent actual positions of cities and towns on the Earth. This is in part the objective of this study, while also using it to calculate the distance between points. This will be of immense help in travels and tasks. In this section, we will deal with the distance between points on the same latitude but on different longitudes. For example, the points A and B, which are on the same latitude but on different longitudes. In cases like this, it is useful to recognize that AB is an arc, alright, and it is the distance between the 2 points A and B that we will be trying to calculate. In finding the distance, the only problem will be getting the angle of sector AOB. You remember in plane geometry when we dealt with how to find the length of an arc or the perimeter of a sector. You remember the equation we were using then? Length of an arc is given by theta times 2 pi r over 360. If you have problem with this equation, you might need to visit our home tutors module on plane geometry, where we dealt extensively with issues about sectors, chords, and arcs. Now, since both points are on the same latitude, the angle of sector AOB will be the difference between their longitude. Remember, we said that if point A is on a longitude theta 1, what it means is that the angle between a line drawn from A and the Earth's polar axis is theta 1. Alright, and if point B is on a longitude theta 2, what that means is that the angle between a line drawn from point B to the center of the Earth makes an angle theta 2 with the Earth's polar axis. Therefore, the angle in between these points will be equal to theta 2 minus theta 1. And take note that r is the radius of the Earth, which is 6,400 kilometers, and theta is the difference between the longitudes, like we just explained. This is the Earth's polar axis. This angle will be theta 1, which is the longitude of A, and this angle will be theta 2, which is the longitude of B. Therefore, the angle within the sector AOB will be equal to theta 2 minus theta 1. That is the longitude of B minus the longitude of A. Example 1. The position of Libreville in Gabon and Kampala, Uganda to the nearest degree is 0 degree north and 9 degree east, and 0 degree north, 32 degree east respectively. Calculate their distance apart along the equator. Now, this is Libreville. We are told that the longitude is 9 degree east. What that means is that the angle formed between a line drawn from Libreville to the Earth center makes an angle of 9 degrees. So therefore, this small angle is 9 degrees. This is the position of Kampala in Uganda, okay? This is Libreville in Gabon. This is Kampala in Uganda. What this means is that the angle formed by a line drawn from Kampala to the Earth's center forms an angle of 32 degrees with the polar axis. Therefore, the angle of interest, that is the angle between the sector OLK, will be equal to 32 minus 9. Alright, so the required angle is angle OLK, which equals to 32 minus 9, which gives 23 degrees. So taking 2 pi equals to 40,000, you can confirm that since 2 pi r is 2 times 22 over 7 times r, and r is 6,400. So approximately, for practical purposes, we take 2 pi r to be equal to 40,000. So therefore, distance between L and K, which is the length of this arc, is given by theta times 2 pi r over 360, which is 23 times 40,000 over 360. That gives us 2,556 kilometers. Example 2. 2 points X and Y lie on the same meridian. Their latitudes are 15 degree north and 36 degree north. Find the distance XY along the meridian. Okay, so in this case, points X and Y are on the same line of longitude, but we are told that they are on different lines of latitude. X is on a latitude of 15 degree north. What that means is that the angle between a line drawn from X and the equator is 15 degrees. Then we are told that Y is on 36 degree north. What that means is that a line drawn from Y makes an angle of 36 degrees with the equator. So therefore, the sector of interest is sector XOY, and the angle within that sector is 36 degrees minus 15 degrees. So therefore, the angle of sector will be 21 degrees, and therefore distance D between X and Y, which is the length of an arc, will be given by theta times 2 pi r over 360. So theta is 21 times 2 times pi times 6,400 divided by 360. That gives us D equals to 2,345.7 kilometers. Example 3. Sidi Barrani in Egypt and Gaborone in Botswana both lie on the longitude 25.9 degree east. Alright, both of them lie on the same line of longitude. Their latitudes are 31.6 degree north and 24.8 degree south, respectively. The question says, calculate the shortest distance between the towns. As I will be telling you later as we go ahead, that the shortest distance between any 2 points on the Earth's surface is their distance along a great circle. and every line of meridian is a great circle. Every meridian, that is every line of longitude, is a great circle. So also the equator, which is the largest line of latitude, is also a great circle. But every other line of latitude are not great circles. The concept of great circle means that when you are dealing with that particular meridian, the radius that you will be using is the radius of the earth. So every line of longitude has a radius approximately equal to 6,400 kilometers. Now, these 2 points are on the same meridian. However, one of them is on a latitude of 31.6 degrees north. So this is what it means. It means that a line drawn from this point to the earth center will make an angle of 31.6 with the equator. All right, and then we are told that the second point is on a latitude of 24.8 degrees south. What that means is that a line drawn from this point to the earth center will make an angle of 24.8 with the equator. So this is the illustration of the problem, and therefore the total angle of the sector that we'll be dealing with will be 31.6 plus 24.8. So the angle of the sector is 56.4 degrees. Therefore, the distance between the 2 points, which is the length of an arc, is given by distance equals to theta times 2 pi r over 360. So that is 56.4 times 2 times pi times radius is 6,400 over 360. That gives us the length of an arc, which is the distance between the 2 points, of 6,300 kilometers.